Welcome back to another lesson in our Common Core Algebra 2 series. Tonight's topic will cover two things: shifting parabolas and completing the square. So back in Common Core Algebra 1, you've probably done some extensive work on completing the square and shifting or translating parabolas. So we're going to refocus our attention on that tonight. So the first definition we need in our notebook is a quadratic function is in standard form, and let's underline that standard form, if it appears in the form y equals ax squared plus bx plus c. And remember, a, b, and c are just numbers. A quadratic function is in vertex form, so let's underline that, if it looks like y equals x minus h squared plus k. And let me remind you, the vertex or turning point is h comma k. Alright, so let's start with a little review. If the vertex is 3, negative 2, then the parabola in vertex form is. So I'm going to say it's y equals x, and then we're going to negate this, so negative 3 squared minus 2. Okay, so this is my horizontal shift, which gets a negative 3 then, and my vertical shift. So let's go ahead and label horizontal shift, vertical shift. So what that's telling me is I'm going to go right 3 and down 2, make my vertex, and I'll draw my parabola in. Number 2, if the vertex is negative 4, 2, then the parabola in vertex form is, so y equals, if I see a negative 4 for my horizontal shift, I'm going to say that's x plus 4 squared, and then my vertical shift stays the same, so plus 2. So this parabola would go left 4, up 2, and it would open upwards like so. Number 3, if the parabola in vertex form is, let's say y equals x minus 1 squared plus 4, then the vertex is what? Well, again, this is my horizontal shift and my vertical shift. The horizontal does the opposite, so if I see a negative 1, it's actually going to go right 1 and up 4. So again, if I were to graph that, I'm going to go right 1, up 4, make my parabola there. Number 4, if the parabola in vertex form is y equals x plus 7 squared minus 1, then the vertex is, horizontal would be negative 7, and vertical negative 1. So again, I would just go left 7, down 1, and make my parabola there. Now, they're not always going to be given to us in vertex form. A lot of times we have to put them in vertex form ourselves. So to do that, we complete the square. Now, you've probably done this, like I said, extensively in Algebra 1, but they only gave you the nice ones in Algebra 1. So I'll review a nice one, but then we're going to get into some real nasty ones. So here's the directions. Let's make sure we jot them down. Take the b term, cut it in half, which is really dividing by 2. Step 2, take that number and square it. Step 3, add that number, wrap the first 3 terms together in parentheses. Step 4, subtract that same number outside the parentheses. 5, factor the first 3 terms and rewrite as a binomial squared. Then you should have something in vertex form. Okay, so I'm going to go through a nice example, and like I said, we'll get into some real nasty ones. So the function y equals x squared is shown already graphed. Consider the equation y equals x squared plus 6x plus 12. Use the method of completing the square to rewrite in vertex form. So let's start by rewriting our equation. X squared plus 6x plus 12. Okay, let's look back at those notes on completing the square. It said take the b term and cut it in half. Well, in this case, my a, the number in front of x squared, is 1, my b is 6, and my c is 12. So I'm going to take that b term, 6, cut it in half, which is divide by 2, and I get 3. Now wrap that puppy up and square it, and you get 9. So we've just done steps 1 and 2. We took the b term, cut it in half, squared it. Now it says we're going to take this number and add it to the first 2 terms. So y equals x squared plus 6x. We're going to add it, wrap those up in parentheses, and then subtract it. And then we'll keep that plus 12 on the end. So in case I lost you there, let me say it again. We took the number that we squared, we add it, and we subtract it, and we keep this last term by itself. Now these three terms that we wrapped in parentheses should factor real nicely. You'll notice this is x plus 3 times x plus 3. It should work out every time that they're the exact same. So now I can write y equals, there's two of them, that means it has a multiplicity of 2, x plus 3 squared, and then I'll just add these two together. Negative 9 plus 12 is 3. So now you can see I have my parabola stated in vertex form. So my vertex, another name for vertex, of course, is turning point, is going to be horizontal shift, but the opposite, negative 3, comma 3. So now we can easily go back and graph this function. I'm basically just taking all my points and moving them left 3 and up 3. So let's go back to this graph. You don't just make random sketches here. We're going to take this point and we're going to go left 3. So I'm literally going to count 1, 2, 3, and up 3. 1, 2, 3. So this point now becomes here. And I'm going to do that with all the points I have. I'm going to take this point and go left 3 and then up 3. I'm going to do the same with this point, left 3, up 3. And then I'm just going to keep going. 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. And now that I have those perfectly plotted, I can sketch this equation. Okay, so they're going to want you to do this without a calculator. Let's go ahead. This is another nice one, so to kind of make you feel real good about these, and we're going to complete the square and state it in vertex form. Like I said, this is what you've done in Algebra 1, these nice ones. So if you think you've got it, pause it, try it on your own. And if you don't, I can talk it out one more time. So if you think you've got it, pause it, see what you get. So the first thing I did was I found my b term, which is negative 8. I cut it in half, and I got negative 4. I wrapped it in parentheses, squared it, and I got 16. Every time you square something, you should get a positive. So now I'm going to add that number and subtract that number. I'm going to leave my first two terms, add that number, wrap those three, subtract that number, and leave my plus 1 on the end. Remember, these should factor nicely if you did it correctly. X minus 4 and x minus 4. So again, that's two terms, a multiplicity of 2, so I can say that's x minus 4 squared. Add those together and I get a minus 15. So now I can tell you right away that the vertex, or the turning point of this parabola, is 4, comma, negative 15. Remember, horizontal, you take the opposite number. Vertical, you're going to keep that the same. So if they asked me to make a quick sketch, okay, so basically I would start at the origin. I would go over 4, and you should do the same in your notebook. I'm going to go down 15, put my vertex there, and I'm just going to make a quick sketch of what this parabola should look like. All right, so what happens if a is greater than 1? It's messy. So this is the part some of our algebra teachers chose not to do because it gets so messy. But we do need to tackle it in Algebra 2. So let's start with this equation. Y equals 3x squared plus 12x minus 2. All right, let's make a note to ourselves. The first thing we want to do is factor out a GCF. So let's write this down. Factor out a GCF from the first two terms. Okay, I'm not going to do it to all three. I'm just going to factor out the GCF from the first two terms. All right, so I'm going to say y equals, I'm going to pull that 3 out, and I get x squared plus 4x. I'm going to leave a space, and I'm going to leave another space and put my minus 2. Okay, so I only pulled it out of the first two terms. Okay, so now I'm going to complete the square. My b term is now 4. I'm going to take that number, cut it in half, wrap it up, square it, and I get 4. So I have to add 4 and subtract 4. But here's where we have to be really careful. So I'm going to say this is 3 times x squared plus 4x. I have to add the 4, but here's where it gets careful. Let's put a big star here. You have to subtract 4, but you also have to multiply it by this 3 that you took out. So I'm going to say minus, because I'm going to subtract my 4, but 3 times 4, and then my minus 2. So let me say this again. I'm adding the 4 and subtracting the 4, but remember you pulled this GCF of 3 out? You have to put it back in. So as I clean this up, I'm going to say y equals, I have a 3 in front. This becomes x plus 2 times x plus 2 minus 12 minus 2. So I get y equals 3. This is x plus 2 with a multiplicity of 2 minus 14. So now I have my parabola in vertex form. I can say that my vertex is -2, -14. And this 3, we'll talk about what that 3 does in a moment. It does play an effect on this graph. And like I said, I'll talk about that in a moment. But here we have our equation now in vertex form. All right, so let's try another messy one. So the first thing I'm going to do is pull out this GCF of 4. And I'm only pulling it out of the first two terms because 7 is not divisible by 4. So I get x squared minus 4x. I'm going to leave a space and another space and put my 7 here. Because remember, I have to add the number and subtract the number. All right, so my b value is equal to -4. We're going to cut it in half, wrap it in parentheses, square it, and I get 4. So I'm going to add 4. Now here's where you got to catch it. I'm going to subtract 4, but I have to remember to multiply by the GCF. So I'm going to say 4 times 4. So I'm going to keep rewriting. So I get y equals 4. Okay, this is going to be x minus 2 times x minus 2 minus 16 plus 7. So I'm going to say y equals 4, the x minus 2 with a multiplicity of 2, minus 9. So again, I have a vertex at +2, -9. So if they ask me to sketch it, +2, -9, and we've got our parabola. So again, this 4 is going to have an effect on the graph, and like I said, I'll talk about that in just a moment. Okay, sketch these simple graphs on your calculator. So here are our simple graphs that we want to sketch. Y equals x squared. Y equals 3x squared. And y equals 1/2 x squared. So notice what's changing, the a values. Here, my a value is 1. Here, my a value is 3. And here, my a value is 1/2. So I've inserted my graph here, and my colors are a little off, so let me just be clear. Hopefully yours looks the same. My x squared is actually in, blue. My 3x squared is in red. And my 1/2 x squared is in black here. So you notice that a value does change some things, but it doesn't change everything. For example, compare the vertexes. What do you notice about all the vertexes? Well, there wasn't a shift, so everything is centered at the origin 0, 0. But what does change? Well, that a value changes how tight, basically, the graph is to the y-axis. So again, look at my blue x squared graph. If my a value, and here's what we need in our notes, if my a value is bigger than 1, for example, here I used a 3x squared, or maybe a 4x squared, or 5x squared. If the a value is bigger than 1, we call it like a narrow or a compressed. It gets compressed or narrow to the y-axis. However, if my a value is less than 1, but of course bigger than 0, so if it's between 0 and 1, notice it gets wider, okay, than the normal x squared graph. So if it's a half, or a fourth, or a fifth, or 2/7, if it's smaller than 1 but bigger than 0, it kind of widens out. Okay, now we're ready for some problems where we actually have to use the zero product law to solve the equation by completing the square. So we're not going to be done until we actually solve these equations. Okay, and solve means your final answer has to say x equals. So let's just start by completing the square. And again, this is a nice one because the a value is 1. So I'm going to take that b value, divide it by 2, wrap it in parentheses, square it, and I get 25. So I'm going to add that number and I'm going to subtract that number. So add my 25, wrap the first 3 up, subtract the 25, leave the minus 5. Okay, so remember this should be something very nice. I'm going to go with x plus 5 and x plus 5. So I'm going to say this is the quantity x plus 5 squared, so it has a multiplicity of 2, minus 30. Now if I asked you what the vertex was, you could easily tell me negative 5, negative 30. But I don't want to know that this time. I want you to solve for x. Okay, so now my goal is to get x by itself. So the first thing I'm going to do is try to get this squared term by itself. So I'm going to add the 30 over. So x plus 5 squared equals 30. How do you undo a square? Well, if you ever forget, they're on the same button on your calculator. If you look at the x squared button, there's a radical on it for a reason. They undo each other. So I'm going to take the square root of this side, and I'm going to take the square root of this side. Now there's one little catch. When you take the square root, you actually get 2 answers. You get plus and minus radical 30. So I get x plus 5 equals plus and minus radical 30. Now, I'm going to break this radical down if possible. Now, 30 can't get broken down, so I can't do anything with it except subtract the 5 over, and I want to be clear that this is going to go in front of the plus and minus. These you cannot break up. So I'm going to say x equals negative 5 plus and minus radical 30. So I want to be clear I get 2 answers here, and let's kind of stem it off. I get negative 5 plus radical 30, and I get negative 5 minus radical 30. Okay, and of course that's x equals and x equals. Now if you want to grab your calculator and type that in, I'm going to say negative 5 plus radical 30 is approximately 0.477, and negative 5 minus radical 30 is approximately negative 10.477. So what did I just find? Those are the zeros of my graph. So if that's 4.77, and if negative 10's down here, it's a little bigger. Those are the zeros of what this parabola looks like. Okay, so it's not the vertex this time. I'm finding the solutions, or the zeros. All right, so let's find the solutions with an ugly one. Okay, so it's ugly because this a value is bigger than 1, so I'm going to pull the GCF out of the first two. So I get x squared minus 2x. I'm going to leave a space, and I'm going to leave my minus 7 equals 0 over here. Okay, so remember, take your b term, cut it in half. Negative 2 divided by 2 is negative 1. Wrap it in parentheses, square it, and I get 1. So I'm going to add 1, and I'm going to subtract 1, but remember, I got to multiply by that 2, so I'm going to do 2 times 1. So I'm going to say this is 2 times, would you agree this is x minus 1 times x minus 1? So x minus 1 squared minus 2 minus 7 equals 0. So I've got 2 times x minus 1 squared minus 9 equals 0. Okay, so again, if they asked for the vertex, I would say it's positive 1, negative 9, and this 2 is making it narrow, remember? But they don't. They want me to solve for x, so my goal is to get this term by itself. So I'm first going to add the 9 over. So 2 times x minus 1 squared equals 9. I can't square root until this term is by itself, so now I'm going to divide by 2. So I get x minus 1 squared equals 9 halves. Now I'm going to take the square root to kill the square. So I'm going to square root this side and square root this side. The square and the square root cancel, so I get x minus 1. But here I get plus and minus radical 9 over 2. And I can clean this one up. Okay, when you have the radical of a fraction, you're really just going to break it up as radical 9 over radical 2. And I know one of those. I know the square root of 9 is 3 over radical 2. I don't know the radical 2, so I'm going to leave it. And then I'm just going to add this one to the other side. And remember, these are married to each other. You can't break those up. So I'm going to get x equals 1 plus or minus 3 over radical 2. So I just want to remind you that I'm getting 2 answers. I'm getting 1 plus 3 over radical 2 and 1 minus 3 over radical 2. And again, those are my zeros. Well, that does it for us tonight, and we're going to get a lot of practice tomorrow. So if any of this was a little tough for you, remember, go back, rewind, try it again, and we'll be around to answer questions in the morning if you have any. Have a great night.